Hi everyone, welcome back to my YouTube channel. My name is Umoru, and in today's video we are going to explore a diabetes data set and uncover insights about the factors or what factors are linked with diabetes. No machine learning or ML will be conducted at this time, just pure data analysis. Let's dive in. I'm using the Google Colab environment for this analysis, and one of the key features I like is the AI suggestive coding that it gives. So before we continue, I like to show us the data set I'll be working with. The data set is available on the Kaggle platform, Diabetes Dataset, and it contains record from 200 patients and has various features like the patient ID, the age, the gender, BMI, blood pressure, insulin, glucose, diabetes pedigree, and outcome. In this data set, we don't have missing value, so that will save us some coding, and there are no duplicates. That means we have cleaned data already. The very first step here is to import the libraries that I'm going to need for this particular analysis. And this is the code for importing the analysis. The NumPy as NP, pandas as PD. These two libraries are used for data manipulation, whereas the remaining ones, the matplotlib, the pyplot, and the seaborn, are particularly useful for visualizing the outputs or the graphs that will be produced at the end of the day. So I'm going to run these particular lines of code so as to import the libraries, and that is done as indicated by 1 here, and the number of seconds it took to run the code, 1 second. So the very next step is to load the data set that I'm going to be using. I've already uploaded the data set to the environment, as we have here diabetes data set in the CSV format. Using the PD read under the method, I'm going to read the data set and preview the first 5 rows of this data set. With this line of code, I run it, and then we see that we have the patient ID, the age, the gender, BMI, and the rest up to the outcome column. The outcome number 1 signifies the person has diabetes, whereas the 0 here shows that the patient doesn't have diabetes. Next in our data analysis workflow is to see whether it has missing or invalid data in this data set. And one thing is the data set is already clean from the Kaggle environment, as we have seen. If some of the entries had 0, for example, blood pressure, BMI had 0, it would be medically impossible. We would have cleaned and treated them as any and replaced them with median or mean as appropriate, because having glucose at 0 is medically impossible. Nevertheless, we're going to run this code to see if we have any or missing value in this data set. So we have seen that there are no missing values here. And next, we're going to check for the info. We want to see further whether there are missing or null values. We see that the whole 200 entries has no null values. and then the data types are in the correct format. The integer, the gender, just string with objects, and we can work with it. Next, we are going to explore the data, a term known as exploratory data analysis, and we are particularly interested in the outcome. So running this line of code to show the box plot of the distribution, the outcome. And we see that about 110 patients have outcome 0. That means they are not diabetes. Whereas close to 100, let me highlight it from here, that is slightly above 90 of them have diabetes. With this now, we're going to show the descriptive statistics of this data set using the describe method. Looking at the summary statistics, the diabetic patients, that is those with outcome number 1, tend to have higher glucose levels, 154, and also higher BMI readings. So this early sign suggests that glucose and body mass index are strong indicators of diabetes. Next is to see how the features are distributed with histogram. With this line of code, we're going to see how this exactly plays out. We're not particularly interested in the patient ID and the age. Let's see if we find something interesting here. By plotting distribution, we see that most of the patients fall within the normal ranges of BMI, the normal ranges of BMI from 25 to 30. Most of them fall within this range. And same thing with glucose. They still fall within the normal range, most of them. Nevertheless, we still notice that some groups are with high values. For example, this glucose has here those with 180 to 200. We still have them. About 2 to 3 patients have these high values. These outliers are mostly or are often associated with diabetes cases. Same thing with the insulin values. So let's continue to see and explore the relationship with outcome, individual parameters with the outcome. Firstly, we're going to see how the BMI relates with the outcome. So using the Seaborn library and the box plot, we see that the outcome of those that are diabetes, that is with 1, are kind of higher than the outcome of those that are not diabetes. They have higher BMI values. The entire box plot is showing that they have higher BMI values, and that is how it relates to it. The same thing, we see the box plot of blood pressure with the outcome. It's also higher. We view the box plot of the insulin and the outcome, same pattern we observe in all these other parameters versus the outcome. And these are clear examples. We see that diabetes patients usually have much higher glucose compared to the non-diabetes. same patterns we observe in the glucose box plots. So next, we're going to view the correlation heat map of these various columns as they relate to the outcome. With this line of code, firstly, we need to drop the non-numeric columns. For example, the gender. Since it is not a number, it's not going to be run. And that is why I had to run the code to drop the non-numeric columns before doing or calculating the correlation. And running this line of code, we see the correlation heat map. And this is confirming that the age, the BMI value, blood pressure, insulin, glucose, and this diabetes pedigree function all have higher correlation compared with other parameters. We see that glucose, the age, they have a strong positive correlation with diabetes outcome. And finally, I'm going to show us how AI can be used to interpret the results. The AI that is embedded in the Google Colab is the Gemini. When viewed, I had already asked it to interpret the result of the box plot initially, and this is what it's saying. The box plot shows that the median insulin for patient, that is the insulin versus the outcome. With diabetes, outcome 1 is slightly higher for those without diabetes. And that is exactly what we find with the insulin results here. Same thing, glucose versus outcome. We see that the box plot clearly shows that the median glucose for the patients, with diabetes, the outcome number 1 is significantly higher than those without diabetes. That is that they are 0. And that is what we see here. The median is slightly higher than the median of those without diabetes. And this is showing how AI can help interpret results. So with this, the same thing with the correlation heat map. Looking at the outcome row or column in the heat map, glucose has strong positive correlation with the outcome, 0.4. BMI and blood pressure also show positive correlation with outcome, 0.21 and 0.21 from the heat map. Whereas patient ID has a very weak correlation of 0.019, which is expected as it's just an identifier. In conclusion, we have learned that patients with higher glucose levels are much more likely to have diabetes. The same thing with obesity as measured by BMI is another major factor. And we also see that age plays a role with older patients more at risk. This shows the importance of how simple data analysis is not just with machine learning can reveal powerful insights. We can better understand the risk factors and guide preventive strategies. Thank you for watching. If you found this useful, hit the like button and subscribe to Maneju Analytics for more data analysis projects. Drop your thoughts or data set requests in the comments. See you in the next video.